So, okay, I just want to show you how to work with processes in background and use a while loop. And I wanted to, sorry, it's spontaneous. It's suddenly coming up situation or use case. Okay, we're here. For example, I have here many files imported from a USB stick, and I wanted to make sure to shred these files. Shred is a program, this one, you can use to shred files. Normally you can delete or remove files with the rm command, but these files you can reproduce it with recovery tools for disks. So, and shred is doing overwriting the file multiple times, so you can't reproduce or recover files, especially sensible files like passwords, personal pictures, videos, sensible data, and whatever. So, and you can give specific options to shred. A moment. We just do man shred. Always look for the manual page of the programs. Sorry, it's in German here. And we use the -n option. That means overwrite the file n times. So I can give 4 is the default for shred. When you don't use n, it will overwrite 3 times the file, and you can change this to 12 or to 38. If you do a research, you would find that there is, oh, I don't remember the name. Is it here? If you overwrite 38 times, it is there's a special name. You will find this. This is a absolutely secure method to erase and wipe out a thing that you absolutely never could restore or recover. So normally maybe 4 times is also not so easy to recover. 12 times is more secure. 33 is very secure. So 38 is the maximum you absolutely need. But this is for absolute secure method. We have the -u option. This is normally very important. This means after you overwrite the file, also do remove the file. If you don't use it, it wouldn't remove the file. It would just overwrite the file with urandom, I think, and then with -z set, you overwrite the file at the end with null, with zeros, to hide the shredding. Okay, this is this. Did I forget? Okay. we go back here and we see I started a shred command here, and this will be finished yet. I send it in the background with this sign. Okay, S is the alias for sudo in my case. I use it so often, so I did the alias. And here we see shred -u is removes the file. Z0 is overridden with null, with zeros, and F is forcing, and N is the amount of numbers to override. Okay, and I set it in the background. So, and if you want to do many shredding processes in a list, you just start a process, and I prefer not to let run 4 shred processes in the same time. So how is it possible to execute many processes after another? You start one, and then I create a line. I always use this. I also send it in the background, so I write the whole command in the curly brackets here, this one. Important is to do a semicolon after the commands you want to send in the background, and semicolon and 1 space, and then the closed curly bracket. This is important. If you let drop the semicolon, you will get problems. So this is important for the execution. And the and sign, this sign, sends the whole command in the background. So if you don't use the curly brackets, it may be only send in the background the last part of the comments. So this is why you use the curly brackets. And then explaining, we have here a while loop. The main part of while loops is while semicolon. Here's the test command, or the command that will check while this command, or often you can use the command test to check option, and while this is given, then semicolon, then do, and then the list of commands you want here that will be executed in the while loop, then a semicolon, and then done is the end of the while loop. This is important. So while, do, done is mainly the while loop. And then while the shred process is running, do sleep 22. This is the while loop I want here. So that means I don't want to execute the next shred command while another shred program is running. Okay? So in this way I can create a list of commands that will be executed, and I can automate many processes and start it and make a list, and it will be executed, and I don't have to care. Maybe it is a very long time running, so I can create many things of commands here without writing a new script for this, and then I can execute it, and I can go for a walk, eat something or so, and let it be executed. So this is absolutely great. So I don't have to wait manually that the first command is finished and then start manually the next command. It will be done automated. I also use this to create tar archives, for example. I also use this to back up my qcow2 images and so on. This is also always for commands that use a longer time. So that is this. So and now I will show you. I will shred, for example, the pictures tar.gz and the dkim tar.gz and this one and this one and this one. The first two are already shredded, and I will start now. I think we start with the dkim screenshots. Yeah, we start with this one, then we start with this one, and then we do this one, I think, or start with the little one. Okay, I show you. Now I just start the first mnt, and here I type in, for example, dkim screenshots. I just do it this way. I do here 33 now, just for the showcase here. I normally would just use 12, for example, so it is not using so much time, but for me it's good in this way, in this case. Yeah. And also I can change it here to sleep only 7 seconds. So this will be executed instantly because no shred process is running yet. I do it in the background with jobs. Jobs. I see now the process is running in the background. I see here, already running sudo shred. This one is already running. This is the first shredding process. I thought that it is finished, but it's already running. And we see here, this is also running. This means the while loop is running, and this process is already waiting. So this is in the list, and now I can check, for example, pgrep shred, and we see one shred process is running. We do a ps-aux pipe to grab shred, and we see here that we have running. I think this is the same. This is running, and also this is running. Did I forget something here? No, this is, I think it, this is all the same. So I see here the processes. So now I want to create the next line, and the next line will be, I know now that it uses more time, so we can just take pictures, and here we change this to 12. So it waits. I do it, the more comments I do in the list, I change the sleep seconds to a higher value, so it will be executed later. So it is the chance is more that the other process is running before. I send it in the background. And now we see the third job is running in the background. We execute jobs, and now we see 1, 2, 3. We also could get the we also could yeah, I will show you. We also can get this process in the foreground. We do just, when I do FG, it takes the last command that is standing in the background that will be get in the foreground. But I will specify %1, I think is it. Yeah, now you see I get the first command in the foreground. Now the bash is not executable because I have the process in the background. Now I can with ctl z I can stop the process, so I can also execute a new command on the command line, and with bg I send it in the background. So you see here now, here is angehalten, means stop in English, is stopped, and now with bg I send it in the background. That means the stopped process in the back is sent in the background, that it is not already stopped, instead running in the background. So I do jobs, and here we have now already this process läuft. In English means running. So you see here I get the process in the foreground and I stopped it and send it in the background, that it runs already in the background. Also these other processes are running here, but not the shred command is executed because he stands in the while loop while one shredding process is already running. So now I send a for the fourth line, and I take qemu, yes, this one, and here I do, for example, 60. That means or you also count 60 is seconds and 1 m is 1 minute. It's both possible. So wait 1 minute and then shred this. I take this down to 12 because I don't want it to take it so many times, because this file is the biggest. So, and I send it in the background. Now you see 4 is here the number, and we do jobs, and we see here 1 is running, 2 is running the while loop, 3 is running the next while loop, 4 is running the next while loop. And so I have a list of jobs running in the background, and my command line is not blocked because I send the processes in the background. And this is, I get information when a process is finished. When a process is finished and I do type something, for example, no, I don't do this here, df-h t x4, do I have a file fat? I think so, file fat. And if I type a command, I would get an information when one job in the background is succeeded, is finished. Yeah, then it would, yeah, if I type enter, a command enter, it would show me job number is finished. So I have also an alias command. Alias G is for jobs. So I just can type G, enter, and I see the list of the jobs running in the background. This is how I can work with. And for example, I have here D or so. Where I am. DFM. So we see here we have the USB stick where the thread processes are running. We have here qcow2 images that are mounted over qemu-img nbd and nbd1, nbd0, and I have LH is alias, is the alias command for ls-lh, for example. But I can also, I don't know, is it a problem to change the directory? I let it here, LLH/media nbd1, and now we see here I created a qcow2 image, for example LLH qcow2 data, here. This is a qcow2 image. I created a qcow2 image here on my main disk, and I think I give it 8 GB. qcow2 images is a image, for example, to install a virtualization virtualized system. Sorry for my English. I already learning. You can install, for example, Debian, Ubuntu, or something into a qcow2 image. There you could also use .img image. This is the raw file image, and the qcow2 image is better because you can give it is a virtual disk mainly, and you can give the disk space for an image. For example, I give here 8 GB for this image, but the .img image would be used directly the whole 8 GB on the disk. And the qcow2 image is better because it only uses in real on the disk the space that is already really used in the qcow2 image. So it is only growing the time you use more disk space in the image himself. So this is why qcow2 is really better. You can create a new qcow2 image with qemu-img, create qcow2 test image.qcow2. For example, this is the name. So qemu-img, create the name, and then you give the space. For example, for G. For G. Oh, I forgot. I have to give the file system qcow2. I have to specify the file system, the type of the image. I have to set here. It's important. So, and 4G is the size. Created, And now I just show you I can check qemu-img info qcow2 test image, and now we get an info, and you see here virtual size 4 gigabytes. Okay, but also you see the real used size on the disk is only one this carbide image, where mainly nothing. Now I show you ls minus lh. Here you see the real used size is nothing. Also I can create qcow2 test image. Let it this way. I show you image, a raw file. Then I type raw. I think this is this one. So img is the raw file, and this will instantly use the whole 4 gigabyte. I show you formatting. Is it done? We do ls minus lh, and now you see here on the disk it uses directly the whole 4 gigabyte. So this is the difference between img, the raw image, and the qcow2 image. Yeah, qcow2 only uses 193K, and this uses already directly the whole 4 gigabyte. So this explained here. What could I show you also? Important is then, if you want to you can use a qcow2 image. I will stand here with the qcow2 image. You also could the img image. But I will show you, this is a good example, how to use this image. You can use it to install it. So I can, for example, I show you alias qdry, qemu-dry 3. Okay, you see here I have this alias to start qemu-3 start. This is this. Do I get this here? V alias, V is alias for nano, for example. So I'm very fast with this. .bin qemu-3 stored. So I show you this is just the script for starting sorry. Oh man, but I want to learn more and more English. This is to start a system, for example, a Ubuntu or Debian system in the virtualization as a qcow2 image. So qemu minus system minus x8664 enable kvm is the kernel virtualization manager, I think. So it is running faster than minus CPU host, means use the host CPU. It's also important to get it fast. And SMP is giving the used kernel. For example, here on the system I have 4 kernels in real, and I only give 2 kernels for the virtualization. And then M is the memory. I give 3 gigabyte for the virtualization system. Then audio, pulse audio, model HDA, then display, GTK, comma, window minus close minus off is I don't want to close this window as failure, so I could only go over the menu to close it, or if I shut down the system, the virtualization system. Show minus menu bar means I don't want to see the menu bar by default, and then I give the HDA the first disk is this. So I have automatization. I use i3 window manager, and I created in this script the autofocus. I have many workspaces in i3, and if I am on the terminal, I only show the terminal, and I want to execute the I want to do the virtualization, and I want to do it complete automatical. By default, it isn't automatical, so I had set the qemu program to a specific workspace, and I have to change to this workspace manually, and I automated this with a script, with a focus script I have written. So I start the virtualization, and it will automatically focus to the qemu window. And after it is executed and I finish and end the process from qemu, it is focusing back to my terminal window. I will show you. Close this. For example, over here, reduce case, go up, create a new window. For example, GVB is, this is my virtualization directory. Here I have many systems. qdry is my alias to start a system. Let's do BSP VM book, and now I enter, and you will see it will directly jump to the window and starts the system. Bam, there it is. This is the, and now you see here up on the top, this is a menu bar I showed in with CTRL plus Alt plus M. And over this I can change things. Here I can close the hard close of qemu, but I don't want this yet. So I start the system, for example. I can switch manually back on to my terminal window, you see here. But I will stay here for the virtualization. So this is this. For example, I will show you, this is just the Mate desktop. I love the Mate desktop. It's very clean, very small, but I don't want to do things here. I just want to show you I use the qcow2 images for virtualization. I also have here the qcow2 image, you see here. Then I have a fresh roll testing Debian, Debian SID also, and so on and so on. I also will show you again qemu-img info, the information of the qcow2 image. Here you have qcow2 virtualization. Virtual size is 5. This is the whole size I could use, but currently only 3.9 GB are used. And you see it also here, only 4.0 GB are used. So this is this one, and I think we go back to the other image. Oh, what is this? He asked for a sudo password. Did I forget this? Did I forget this? Oh no. Oh, let's check. Is it? So I send it on the background. List my jobs, and now we see I clear. G is jobs. You know, this is this one. Now the second job will be running, I think so. Dchem. Okay, now he chose. Yeah, this is a false. Now let's check pgrep shred. This shred process is running. psrox grep shred. Now we see, oh, terminated. Okay, this is all the same. This is running. Okay. Yeah, the problem was I did the sudo in the process in the background. The problem is, to make it better in the future, it's important to, where do I have here? This is the line. To make it better in the future, it is important to change this to sudo bash -c and do it here in this, yeah, this one. So the difference is, when I have here the sudo command, sudo will be asking again for a password after a few minutes. So when I start many comments in the background, it will get a problem, because when I go away, he will ask for the password, and so the whole process is not running because I have to type in the password. So that's a problem here, and this is why this is terminated, because it is waiting for the password in the background. You have seen this. We had 2 lines here asking for the password. So I have to get the process in the foreground again and type in the password to get the process executed. And this is was my failure here. I forgot this. I have had to do it in another way. So, for example, this would be possible to put it here in this and this. So I would execute the whole process as sudo. Sudo bash -c means execute a bash shell and execute a command between these 2, I don't know exactly the quote. But this would be possible in this way. And in this case, we could delete the curly brackets, for example. Yeah, I think this would also be possible. Yeah. I just do x, y, a, z, z. Check this. So now you see also this is possible. We started the whole process in the background and the whole process is running as sudo. This is better. You also could, what is it not here? Yeah. Okay, let's look up here. What also would be possible, I think, is to start sudo start a command, also set the sudo command before the curly brackets. I will check this here. Isn't it's just an example for showing you up. And now we start the whole command in the brackets with sudo. I'm not sure if this is okay. Here we see a syntax error. So this is not possible. It's good for a showcase. You can learn and try things. So I also had to set this in with bash -c. So the better case is just do it this way directly and send it in the background. So this is this. Let's check out jobs, and now we see here this is running, this is running and waiting, and this is running also. And this I executed in the background here. This is a sudo bash -c, and this in the quotes. And now I can show you how I can get a process in the foreground, fg. Now I have here, you see here pictures.tar. This is this one. So now he sent the process 3 in the foreground, and I could type the password in, but I stopped the process already, and it is in the background. J, and now I clear the screen. J, and now you see here, here steht angehalten. That means the whole process is stopped now. Okay. And if I type again fg, he already asking for the password. I don't want it yet. And now you see angehalten means stopped. I have to set up a system in English, so it is better to explain. G jobs, and now we see stopped is running, and this is also stopped. Okay, both processes are stopped here. Now I want the 5th program, and I do fg for foreground %5. So I get the 5th process in the foreground. You see this? This one is here. This one. This is now in the foreground. And I also want to stop this with ctrl Z0. So this one. Now I take jobs, and now we see angehalten means stopped, angehalten means stopped, angehalten means stopped. So I only have running the process 4 now. Yeah, and I will check this htop, and now you see here vocal screen is running, pulse audio is running, and where it is, can I search filter F4 shred? Yeah, now we see all shred processes here, and you see here shred is running. No, he says it is dead. I don't know why it is dead. Terminated means it is waiting. It's stopped now. These are the processes in the foreground, and now you see sometimes the process is jumping. So okay. Yeah, also here it shows the whole process, because this process is set in the quotes. So this is this one. And you see load average is at 3.10. Yeah, I think so. Okay, it needs some time. I close htop here. We can show up top. Also here we can see the shred process. So, and J. And then ps-aux grep shred. Also I have an alias for grep. It's just a bit shorter, grep. I have an alias for grep n and grep e. I use this also. Yeah, here you see all the processes. I'm not sure yet. I open bpytop, and now we have a whole system overview. And we see here all the disks. I want to see this part bigger, and I type 4, the 4, to hide this. I also could hide the network with 3, so I have a big overview over the disks. So here's the loop disk, Debian ISO loop mounted. Then we have the EFI. Then we have what is this? Used 1%. Yeah, okay, this is this. Then we have MNT here is running. Here we see that it is writing on the disk, and I think this should be the shred process. Yeah, and it's writing to MNT correctly. Yeah, so that means MNT 19 megabytes writing. The summary, the whole size of the disk is the USB stick, 114 gigabytes, and I/O. We see here the process is writing and writing and writing. This is what we want. So, and NBD1 is the mounted NBD, the mounted qcow2 image over qemu-nbd. And NBD0 is the other mounted qcow2 image. Yes. So I created a qcow2 image to put all the data from the USB disk in. Why I do this? It is good because, for example, sensible data. When you put sensible data directly on your big disk and you forget to shred it and just remove it, you will have all the sensible data in the bits and bytes on the disk, and it could be recovered in the future time. So if I want to make sure that the sensible data stays sensible, I create a qcow2 image and put the sensible data only in the qcow2 image, and then I make sure, yeah, it's very easy because it is like a container, okay? And then if I, for example, I sort the images out, I collect the secure passwords, the sensible data, and so on, and I choose which I want to save and which I want to remove and shred. So, and then I do sort all the stuff, and after this I copy it in a smaller qcow2 image and do it in my store, save store, and the other stuff, the temporary qcow2 image where I sorted all the stuff, is already there, and then I can shred the whole qcow2 image, and the whole stuff will be shredded and yeah, the whole stuff will be shredded. So, and I make sure the container is shredded, and I have no little parts of the sensible data on my main disk. It is absolutely safe in this case, in this way. So this is the possibility with using qcow2 images. And now we see it isn't writing on the MNT on my USB stick. The load is going down, and we see here no writing anymore. I close bpy-top, and now we see we have only 3 processes in the background. And now I choose which process I want to start again, and I want to start which I want. Why is this? Also picture start GZ. This is a bit faster, I think, so we do first the pictures. 3. So I take FG %3, get it in the foreground, type the password in, enter, stop it, and then BG, send it in the background. It's running in the background. I open bpy-top, and we see here the next shred process is running. So this is just a showcase. If I would do it correctly with sudo in the quotes and so on, and I have it in the while loop, it would be executed complete automatically. Oh, we see it's already done. And now we see here, fertig means finished. Okay, this is what I meant. A background process will show up when it's done. G, oh, we have only 2 processes here. Now let's get this one. Foreground, process 2. Yeah. Type in the password. The background. You see it's running in the background. bpy-top, and we see here it is running. And I think shouldn't be so long. So this is I wanted to show you. Now is it going down? I close it again, the job list, and now you see läuft means running in the background, this one. And then I have a stopped process here. This is just the example process, epsilon-xz. So I want to show you how to kill a job. Just type kill %5. Kill jobs, and now you see here is cancelled. Beendet means cancelled in English, so it shows up just in this case. And if I type again jobs, you see only the last running process is now here. H-top. Let me see a bit. bpy-top. bpytop is better because you can show the I/O of the disks. But there is another program, I think so, IOstat. Yeah. Oh, how was it? Minus delay 2. Yeah. Again, yeah, that's it. Minus D2 is every 2 seconds the delay, minus D, show up the write I/O write of disks. So here we have some NVMe is the root disk of my system, and SDA is the USB stick. And we see here the highest number of writing is on the USB stick. So IOstat is also very, very good. There's already also a program ifstat for networking, also very good. But IOstat also S is possible, I think. It's short, but this is a long way. This is good. Man IOstat, read the man page. It's always very important. Minus human is also possible. No. Yeah, minus human. And then yeah. Okay, so we can start H human readable format and D delay every 2 seconds. Yeah, human readable here. Okay, human readable and pretty is, you see here 14 megabytes, and here you see the disks is on the left side. But I think this is easy readable because you see the whole long line, and on the first view you see, okay, this is writing here. So this is how I can monitor processes that using the disk, okay? Because while shredding, the CPU isn't used so much, but the disk write I/O is the thing I can monitor better here. So this is this, very easy. And now you see, it seems that it is finished, because all is going down to 0 on SDA. Okay, great. And now I stopped IOstat, and you see here, the background job shows me fertig. The process is finished. This process is finished. So let's do jobs, and now we have no output. The job list is cleared. Every job in the background is finished. DFM, we see here MNT, and we see LH, MNT. We see here all the files are shredded. I only have now the imported ISO star.part_tar. Yes, that's it. I think I will record a new video after this to show you how can I split a huge tar file and set it together. Here you see I have a huge tar file split it in many 3 gigabit parts. The whole tar file was 54 gigabytes, I think. This was amazing. I had this tar file on my mobile phone, and I want to get it out of my mobile phone, and I had problems because on the USB stick I put in was the FAT32 file system, and this is limited to 4 GB size of files. So I had to split the huge tar file to less parts, and this I did. Now afterwards we have to put all this stuff together to unpack the tar file. But this is just what I wanted to show you here. And the files I deleted are these ones, and I packed this in the qcow2 image. So we have here nbd1, this is this one, lsblk -f, grep nbd1 nbd. So and we see here this is the qcow2 image is connected to nbd1 part 1 h qcow2 data. I think that's it. This qcow2 image is connected with the command is qemu-nbd -connect dev nbd 1 part 1 nbd1 to qcow2 data. This is to connect a qcow2 image to the qemu-nbd virtual disk, and afterwards if I unmount the image, I have to disconnect. I do blah blah blah, will not found this, just so I want to sudo mount dev nbd 1. For example, I disconnect. Maybe it's not important here. No, not mounted, and so do this one. Yeah, sudo unmount dfm. It's unmounted, and now we have to this nbd -d for disconnect, and then dev nbd 1 disconnect the, but I will show you lsblk grep nbd 1. So I show you here this is executed before. This was nbd1 part 1, 8 GB disk, permission denied. Okay, here we have, I have to do it with sudo disconnected, shows up disconnected, and we show here not found. Yeah, okay, now we see nbd1 shows 0 byte. So this means the qcow2 image is disconnected from the virtual nbd device. Okay, nbd is the whole is a virtual disk where that I can connect to a .img image or a qcow2 image. So when I do lsblk, you see the whole stuff here. Here you see the virtual NBD disks 1, 2, 3, 4, 7, 8, 9, 10, 11, 12 until 15. So, and I have already connected to NBD 0 is connected and mounted, a 8 GB disk. No, I'm not sure yet which image it is. LLH qcow2 test. Maybe it is. Yeah, I think it is the test split image. So okay, I will stop here. This is about qcow2 images, mounting, monitoring, shredding, processes in the background, and so on. It's just spontaneous. It's not perfect. Just showing how you can manage all the stuff. Yeah, you have to read the man pages, try things out, learn to use images, create images with qemu-img and so on. And maybe I create a future prepared explain video that's more structured. This is just a spontaneous video to show you some things. Okay, have fun, learn, never stop learning.